Hello, Suzuki.
Yeah,
Sensei.
good afternoon and good evening and good morning. I'm Kei Suzuki from Kagawa University. Today, we have two invited presentations. The first one is from Tsukuba University, Professor Itoh Sensei. He talks about overtrust in fully reliable systems. He's a kind of the pioneer in the field of the trust calibration, as well as the shared control and adaptive automation. So I hope we can have a fruitful discussion. After that, our second keynote talk is from Honda Research Institute, United States, by two presenters, Dr. Kumar and Dr. Teruhisa. This is also quite interesting, the proposal of HMI device to minimize the discrepancy in terms of the ODD. So, Dr. Lu, let's start the Professor Itoh's presentation, please.
Hello, my name is Makoto Itoh. Today, I'd like to talk about trust, reliability, and limitation of trust in fully reliable systems. I would like to start from one question. Suppose an automation is fully reliable in the sense of the reliability engineering. If someone says in this case, I fully trust the automation because it is fully reliable. Is it overtrust? That is a question. The answer would be yes. Answer could be yes, even if the automation is fully reliable. Why I do think so, I would like to explain. So, what is fully reliable? There are two meanings. One is the automation is never broken. This is related to the reliability in a narrower sense. And in addition, the second meaning, the automation always works as designed within the operational design domain. So if these two hold, yes, we could say the automation is fully reliable. In reality, there is no machine automation that is fully reliable, but I would like to think about the automation that is fully reliable in this presentation. So if this automation is fully reliable, it looks okay, everything looks okay, but still, even a fully reliable system may not work beyond the operational design domain. Yes. So if the human operator relies on the automation beyond the operational design domain, unfortunately, we would like to say it is overtrust. Yeah, I think so. So I would like to discuss how and what the trust in automation looks like if we take the reliability and operational design domain into account. So many years ago, I proposed a very simple model of trust in order to discuss the overtrust and distrust. In that model, I took two things into account. One is the difficulty for the automation. This is related to the ODD, operational design domain. In my model, I defined the notion of automation range within which the automation must work, the designed specification, the condition. And so within the automation range is corresponds to the operational design domain. Anyway, within the automation range, the automation must work. So the probability of the automation works as designed must be 1. But within beyond the ODD of the automation range, the automation may not work. So it looks like this. With this framework, we could discuss the shape of trust. In order to discuss the shape of trust, I would like to use the Muir's dimension, Muir's model of trust in automation. Muir applied the model of trust, which was proposed by Rempel et al. From the social psychology domain. The trust has 3 dimensions. One is predictability, and second one is dependability, and third one is faith. Predictability represents the consistency and desirability of past behavior. Dependability represents an understanding of the stable dispositions that guide the automation's behavior. The faith is the conviction that the automation will behave as expected in unknown situations. So, on the framework, I put these 3 concepts, and it looks like this. Suppose the human operator has some image, the range within which the automation should work. So I call it the range of phase F, from here to here. Within this, the human operator basically expects that the automation should work, but on the basis of the previous experiences, the human operator may have some feeling that in some conditions the automation cannot work. So I represented the range as UD, undependable. And on the other hand, based on the previous experiences, the human operator may have feeling that the automation can work as expected within some area. I call it this D, dependable area here. And in between dependable and undependable, there is another area, which is unpredictable, UP, which means the human operator has no confidence whether the system, the automation is dependable or undependable. So the dependable and undependable areas would be related to predictability, and this corresponds to the dependability as a one dimension of the Muir's trust, and F is yes, this is faith. So I believe the trust of the human operator has this kind of structure. So, and for each condition, the human operator could have some quantitative willingness to rely on the automation. For example, on this condition, the human operator regards this is useful. That the human operator is willing to rely on the automation. Here, for example, the human operator does not feel this is the automation is useful and cannot be relied on. So I think the overall subjective feeling, if the human operator is asked to rate the degree of trust, that would be corresponds to the area, the size of this area. This is related to the rate of the subjective feeling. Yes. So if I use this framework, I can discuss the several types of trust. Let me show you some examples. One is this. This is a full trust. I mean, the human operator fully trusts the automation. But that full trust is appropriate. Let me explain. This is the range of automation, and this is ODD, and the ODD is completely exactly the same as the width of phase and the width of dependability. I mean, so this human operator basically express the automation should work within the automation range, and based on the previous experience, the human operator regards the automation is trustful. The human operator is willing to rely on the automation. So in this sense, in this case, the human operator could say, yes, I fully trust the automation, but I don't think this is overtrust. This is appropriate trust, I think. Another example, I think this is the overtrust. First, the range of phase is greater than the automation range, the operational design domain. And based on his or her experiences to interact with the automation, the human operator regards this area is dependable. That would be, I think, that would be partly because the human operator misunderstands the actual condition. I mean, the actual condition is here, for example, but the human operator regarded the current working condition is here. So based on that experiences, the human operator regards even in this on this condition, the automation is useful, dependable. This is a kind of due to the misunderstanding of the working situation. But anyway, this could be possible. So if the trust looks like this, it could be regarded as overtrust. Another example is like that. Again, the range of phase is greater than the actual automation range, and due to the less experiences of interacting with the automation, the range of dependability is relatively smaller like that. But still, the human operator thinks that this is unpredictable. I mean, the human operator is not sure whether the automation is reliable or not. in these on these conditions, in that case, still it could be overtrust. I don't know, but it cannot. It may not be overtrust, but I guess it is a kind of overtrust anyway. So anyway, what I would like to claim here is that we could discuss this kind of several cases of trust with this kind of with this model. So I'd like to close my presentation. Finally, I'd like to say one more thing. So if the proposed model, I believe it is useful to discuss trust more in a more detailed manner. But there is one discussion: is the limitation of the automation clearly determined? So how to calibrate? I mean, how the question is how we can make it appropriate the human trust in automation. If the actual limitation is clearly defined like this, it will be easier. But in the reality, the limitation is somewhat vague, or in addition, the designer's model of the designer's model of operational design domain could be different from the actual ODD. So this is very difficult discussion about how to match the user's actual model of ODD to the system's actual ODD. This is very difficult question, but still I think this is worth discussing. So that's it. I thank you very much for your attention. I'd like to close my presentation.
So thank you very much, Professor Mark Itoh. So it's quite interesting talk about the structure of the trust based on the Mueller's dimensions. So now we will start the question and answer session. So if you have any question and comments on the Professor Makoto Itoh's presentation, can you turn on the microphone and talk to each directly, or please give us some message on the chat box. So does anyone have any comments or questions? Okay, Dr. Liu.
Yeah, thank you very much. Thanks, Professor Itoh. Thank you for your presentation. I have a very quick question. That is, what difference between the dependability and reliability?
Sorry, excuse me?
What difference between the dependability and the reliability?
In my presentation, dependability is one dimension of trust. So this is very subjective issue. But on the other hand, reliability, this is a more objective and engineering. I use the reliability from the viewpoint of the reliability engineering.
Okay, thank you very much.
Okay, anyone have another questions? So please, Alexander. Please.
Hey, hello. This is Alexander of Nagoya University. So thank you for your presentation. In the very last part, where you addressed different perspectives regarding the ODD. So how should we proceed in a way that be able to define, because we are working to define the ODDs that satisfies what we as designers, for example, consider the important criteria of the environment, but the actual ODD and the user expected ODD are different. So how shall we work towards realize something that maximizes or that reduces the differences?
Good question. Thank you very much. First of all, sorry, I forgot to prepare my slide for the Q&A session, so I can't use my slide. But anyway, I think we can match the designer's model and the user's model. It could be difficult to match the designer's model and the actual model. Something could be different from the designer's model and the actual one. So what we could do is to, I think, to match the user's model and the designer's model. And the designers could try to limit the availability of the system within the ODD. But in reality, the system could work beyond the ODD, but you could omit the work the work of the system beyond the ODDs. I think that kind of thing could be one solution.
Right, I understand. So bringing the actual users, those who are going to be, who know the environment and who are going to be using the automated system, together with the designers to at least minimize the difference between these two areas, correct?
Yeah.
Thank you.
Yeah. Thank you.
So another comments and questions? So can I have just one simple question?
Sure.
You are from academia, so I want to have your pure opinions. It's quite important to minimize the discrepancy, the difference regarding ODD among between the designer's model of ODD and the user's models of ODD. So it's quite important to minimize this discrepancy. I think it's important the user educations, not only the HMI device practical use into the market. So that kind of the comprehensive ways to minimize the discrepancy, the difference in terms of ODD is important. So I was wondering if you could give us any comments in that, in the kind of the user educations.
Yeah, that is very important comment. Thank you very much. I think, yes, the holistic approach is very necessary because the education and the user interface, everything is limited. The resources are very limited. For example, you don't have time to, you don't have much time to present to provide information to the user. So even if, for example, in Japan, there is the lecture should be given at the licensing renewal of the driving license. But when I discuss this issue with the police agency, they say only 5 minutes, for example, could be done, up to 5 minutes or 2 or 3 minutes or something like that. So the time length is, for example, it is very, very limited. So the content should be minimized. So in that sense, the police agencies, schools, and the HMI, everything must be used to enhance the education. In that sense, the holistic approach is very, very necessary. Yes.
Thank you very much. So last question is from the Dr. Wang. Yes, please. Wang.
Hello. Yeah.
Hello. Please.
Hello. presentation. It's a very nice presentation. I would like to ask some question regarding this the open question. This question, the limitation of the automation clearly defined. Yeah, I think there are some overlap between designers' model of ODD and actual ODD. Yeah, I would like to ask the question related if this overlap between the designer's model and actual model in some area, if the system in some area in the actual ODD and actually the system cannot handle, but if we need to have this trust calibration, we need to know when the system can't be handled. But even the system doesn't know that. It become then we come into this question that the system don't know what the system doesn't know what he doesn't know. So is there any way we can, from design perspective, to tackle this problem? For example, today a lot of deep learning model are applied, and in deep learning model, it's very, fuzzy and less expandable, and then especially we use some adversarial attack to some CNN model, and it makes sense for human to make sense of the system. Then it's even harder for detect this I don't know what I don't know problem. So is there some way to solve this problem from design perspective or engineer perspective?
Thank you very much. But this is very, very tough question. Yeah, I so far, to be honest, I don't have a clear answer to that question. But one thing could be the system must know what it can do. One way is to limit the activity of the system within which the system is 100% sure that the system can work. That is very sorry, this is very difficult to explain for me, but to limit the activity of the system, that will be one solution. One solution, yes. Sorry. Yeah, to be honest, this is very difficult. Yeah.
Right. I think it's I just jumped into this question for a long time, but I think it's very difficult. But I think maybe there are some design solution we can. Maybe you can enhance the system explainability or interpretability to let human to find out when the system will failed or likely to be failed. Maybe that would be one way.
So the system that are designed based on the previous methodology, that will be a bit easier. But if you think about the AI-based system, the system that learns, that will be another issue. Yeah, in that sense, I have no idea so far.
So this is quite a difficult questions, but is it okay to finish, Dr. Wang?
Yeah, sure.
And now we have information about Professor Makoto Itoh's study on chat box. So please, if you are interested in the Professor Makoto Itoh's research project, could you check it out? The chat box, there's some references, okay? So now we will move to, thank you very much, Professor Makoto Itoh. Thank you very much.
Thank you very much.